All right. Hi, everyone. Good evening again. I hope that everyone is doing well. Happy New Week. It's only Tuesday, right? And as mentioned before, we will be adding a half an hour to class. So we would be finishing at 8:30, and no worries, we usually finish close to that time anyway. So what we will be doing is the first hour. Hopefully it doesn't take an hour, but for the max amount of time is 1 hour. We're going to do a tutorial paper, which would cover everything we would have done so far with regards to decimals and significant figures and standard form and all of these lovely things that we would have learned and practiced over the past 2 weeks or so, right? So I would have sent everyone so you can pull that up for me. And we're going to start. Right, so again, a tutorial is really just us working out questions, right? With your participation, that would be good. Okay, everyone has the paper up, and I am going to start with the first question there. These are paper 2 settings, so we can use our calculators, right? Feel free to use your calculators. So the first question, what I always do is start by writing my actual question, right? So it's going to be 2.8 plus 1.36 over 4 minus 2.7. So of course, there's a first part, there's a top part, which is our numerator, and there's a bottom part, which is our denominator. And we're not just going to plug everything into the calculator, we're going to do it step by step. So the first thing we're going to work out is the top and put our answer. So I go to my calculator and I put 2.8 plus 1.36, and I am getting 4.16. Put back my fraction line, and then I'm going to work out 4 minus 2.7. My answer is 1.3. That's my second step. Now I can put this in the calculator as 4.16 divided by 1.3, which is 3.2. They said calculate the exact value. Therefore, this is the exact value from the calculator, and I am finished with this particular question. Now, part B says calculate 9.72 multiplied by 12.05 and write. So there are parts to this one. They want it exactly. So I take my calculator and I put 9.72 multiplied by 12.05. And my answer exactly how it is in the calculator would be 117.126. And this is my answer exactly, right? Part 2 would be corrected 2 decimal places. And again, we know that decimal places are from behind the decimal point. So that's going to be 1, 2. So that means we have to watch the 6 and we're going to add 1. So therefore, our answer would be 117.13 to 2 decimal places, right? And now part 3, we would say they are asking us to write it corrected 2 significant figures. We go back to our rules of significant figures. Significant figures start from our whole number. So 1. So what we're checking is the exactly answer, right? Not this and then moving on and everything. We always go back to the exactly answer to do our working out. So they said 2 decimal places, we checked it from the exactly. They now said 2 significant figures, we're checking it from the exactly. So it's going to be 1, 2. We're going to watch the 7. So therefore, we have to add 1. So that is going to be 1, 2. And of course, the 7 has to go to 0. And that will be 2 significant figures. And that is part 3. Part 4 now, in standard form, write your answer in standard form. Again, go back to your exactly. And standard form, we have to place the points in a position that makes our number bigger than 1, bigger than or equal to 1, but less than 10. So if I watch it, I can move my point from here and put it here between the 1 and the 1, giving me 1.17126. Right? According to this, I'm going to move my point 2 places to the left. So I would now write 1.17126 multiplied by 10 to the power of, when we move to the left, it's going to be positive. So positive 2. Right, so this is the end of that particular question. We're going to move on to the other question. So they said calculate the value of 0.35 squared minus 0.03 multiplied by 0.8. So exact value means, of course, exactly how it is in a calculator, but we have some mixing operations here, so we have to apply BODMAS, right? Always remember, when you start to see your operations coming together, more than one, we have to apply BODMAS. So we have to work our brackets first, and they are telling us 0.35 squared, so we can put that in the calculator. 0.35 squared gives me, and I'm writing my answer, 0.1225, and I'm going to put back minus, and there are 2 things multiplying there, so I'm going to multiply them 1 time, right? Which is these 2 are multiplying, so I'm going to put 0.03 multiplied by 0.8, and my answer is 0.024. I would hope that you all are doing it in the calculators as well and not watching it alone, right? Get some practicing as I am going along, making sure that my work is correct and that you know how to do it as well, right? And now we're going to subtract the 2. And our answer would be 0.0985. Again, this is exactly. No rounding, nothing. Right? So this is A part 1. Well, just A. Now we're going to do B. That says express 0.0345. Correct. So 1 past 1 says 2 decimal places. So again, we have a decimal point here. So it's going to be 1, 2. There's a 4 after it. So that means it remains as for at 3, we round down. So that's going to be 0.03. Again, 2 decimal places. We always like to highlight our stuff, right? Part 2, write our answer, write our question in standard form. So again, this is what we have to write in standard form, not this, right? So we're going to put the point between the 3 and the 4. And I would have hoped that you all would have gone to YouTube and such. So get your practicing on putting your points in the correct place for the standard form or the scientific notation, right? So we're going to move it 2 places to the right, 1, 2. So our answer will be 3.45 multiplied by 10 to the negative 2. That is the end of this particular question. Let us move on to the other question, which says 7. Evaluate. So evaluate means calculate, right? Evaluate 7.021 over 6.751, which means divide, and express our answer correct. So 3 decimal places. So let's put this into the calculator. 7.021 divided by 6.751. We have an answer of 1.039994075. So I wrote the answer exactly first on paper, right? So I have the exact answer on paper. Now I'm going to give them their number 1, which they requested. So don't leave anything in a calculator and try to, go back and forth. Always write your stuff down, right? Write your answer exactly. Now you're going to take that and give them the answer that they are looking for, which is 3 decimal places. So that's going to be 1, 2, 3. So we know that we have a 9 after it. Therefore, we have to add 1 to this 9. And we know that if we add 1 to the 9, it has to move on to the other number in front, right? We're not just going to put it as a 0 and put 1.030 because that's making the number significantly smaller, right? So we're going to have to add the 1 here, which makes it a 0, and add the next one here, making it a 4. So therefore, our answer would be 1.040. So 3 decimal places. And now part 2, they said so 3 significant figures, and you see another reason why we have to write down our stuff, because by now you probably would have cleared your calculator, but you still have it written down in your book, so you could go right back here and now do your stuff according to 3 significant figures. You have to include the whole number, so 1, 2, 3. We watch the 9. We have to round up, so we're going to add 1, which is going to be 1.04, and this is 3 significant figures. Right, so let's move on to the other question, which is write 0.8909 in standard form. So standard form is the only one where we move the point, making it a number between 1 and 10. So we can easily see that the point is going to move between the 8 and the 9, right? So it's going to be 8.909 multiplied by 10. We moved it 1 time, right? So that's going to be -1. So that was part 1. Now part 2 says correct 2 significant figures. 2 significant figures will be 1 and 2. We cannot include the 0 because it's at the start, and we have to start with our first non-zero number. So that's 1 and 2. There's a 0 after, so we're just going to leave it as 0.89. And this is 2 significant figures. We could move on to the other question immediately. That says, write the value of 11.2 squared minus 0.375 divided by 3. Again, we're seeing a bunch of things, so we are going to apply BUDMAS, right? So we're going to work out the squared first, which is going to be 11.2 squared, which is 125.44 minus, we have to work out what's in brackets as well, 0.375 divided by 3, which is 0.125. I can subtract these two, which is going to give me 125.315, and this answer is exactly. Right, so this is part 1, which is exactly. Now part 2, they are asking for 2 significant figures. What do we have to watch when we're doing stuff after we worked out our exactly answer? The exactly answer, right? So 2 significant figures. We are going to start with the whole numbers, 1 and 2. There's a 5 after, so we're going to round up. Therefore, that's going to be 1, 3. And because of significant figures, the 5 is going to move, and we're going to put the 0. So this is 2 significant figures. And now part 3. In standard form, again, we go back to the exactly. We're going to put our point between the 1 and the 2. So that's going to be 1.25315 multiplied by 10. We moved it 2 places left, so positive 2. And that is standard form. Let us go on to the other question using a calculator, or otherwise determine the exact value of the exact value of 4.2 by 10 to the power of 4 multiplied by 5 by 10 to the power of negative 3. Right, so calculate the value of this. So we have to work this out in our calculator. So we put 4.2 in our calculator, multiply by 10, and we press the power sign, which is this. Right, once we press 4.2, so it's going to be 4.2 multiplied by 10. Then we press this, and then we press whatever the power is, and in this case, we press 4. And we will see it pop up in the calculator, right? And we could press multiply. Same speed, we don't need to write it out. Multiply by, same thing, 5 multiplied by 10. Press this button, and we're going to press the negative 3. And we would have gotten, just erasing this, 210. Now they said to write our answer in standard form. So that means our point is always at the back for whole numbers. So it's going to be here, and we're going to move it 2 places left. So that's going to be 2.1. We don't need to put in the 0. We could put in the 0. We don't need to put it in. Anything is fine. 2.10 multiplied by 10 to the power of 2, because we move it 2 places left.
Excuse me, I have a question.
Sure. All right, so the last question of the tutorial would be number 24, express 0.0402 divided by 0.71, correct to 2 decimal places. So again, I like to write this stuff. You should write your stuff down. 0.0402 divided by 0.71. Put down your exact answer, which is 0.056619718, 0.566197118, right? And now we're going to deal with what they are asking us for, which is 2 decimal places. So 1, 2, there's a 6 after, so we have to add 1. So that's going to be 0.06. 2 decimal places. Part 2, correct to 2 significant figures. Again, we go back to our exact 2 significant figures will be Our first significant figure will now be the 5 because this is a 0 and this is a 0. And we cannot start with any zeros. If the 0 were in between the numbers, like here, we could count it. So this is a good example. If I was saying first significant figure, it would have started here. Second significant figure would have been the 0 in the middle, and third would have been the 2. However, I cannot say first significant figure and second significant figure because those are our starting numbers, which are zeros, right? So we would have to start here and then continue. Once the 0 is in the middle, that's fine. If it's at the start, that's not fine. We start with our first non-zero number. So that's going to be 1 and 2. There's a 6 after, so we round up. So this is now going to be 0.057, and this is the 2 significant figures. And the last one, part 3, we are now going to write it in standard form. Go back to the exactly. I'm going to put my point between the 5 and the 6. So that's going to be 5.66. I could leave it as 5.66. That's fine because I would round it to 2 places. If you want to put back the entire thing, that's fine as well. But I'm just going to round it to, it comes like I'm rounding it to 1, 2, 3, 4 decimal places. And I'm going to, because it's a 1, I'm going to stop at 6. So it's going to be 0.0566. And I'm making this my significant figure. So I'm going to put it between 5 and 6, so 5.66. And we're going to multiply by 10. So how many times we moved it? Which is 1, 2 places to the right. So that's going to be -2. It will be the same thing if we put 5.6619718 multiplied by 10 today. We still move it 2 places, right? So it's still going to be -2, right? I hope that you guys understand that. Now we are going to start a new topic that is entitled fractions. All right, we all know what are fractions. A fraction is a part of a whole, right? So if you have $1, right, $1 can be broken up into many different parts. We could break it into 4 parts, which are 25-cent pieces. So 4 25-cent pieces could give me $1. We could break up $1 into 2, right? 2 parts. And that would be 2 50-cent pieces. We could break up $1 into 100 parts, which would be 100 1-cent pieces, right? So a fraction is made up of the parts over the total. So if I say what fraction is 25 cents out of $1, this is going to be 0.25 out of 1. What fraction is 50 cents out of $1? 0.50 out of 1. What fraction is 1 cent out of $1? 0.01 out of 1.00. And that's basically the general idea of a fraction. When we think about a fraction, we think about part of a whole, right? The largest a fraction could be is 1. 1, generally, if we're dealing with something, you have 1. But if you have less than that one thing, you have part of it. If you have more than that one thing, you have 1 plus the additional, right? So we are going to understand the basics of a fraction now. So the part on top, out of the total, this part here at the top is called our numerator. And the part at the bottom is called the denominator. So we can use fractions. We could add them, we could subtract them, we could divide them, we could multiply them, however it goes. And this is generally something we do in life, right? You want to go and you want to count something up, you're taking out 2 from it, you're going to take out 2 out of 3. Or you have 4 bottles and you want to add, you want to take away 2 and give it to somebody else, you're taking out 2 out of the 4, etc. Everything that we do in some way or form or fashion deals with fractions, right? So what we're going to do is apply the 4 operations, which we know: add, subtract, multiply, and divide. We're going to use these operations and work out fractions, right? But before we get into that, we are going to understand some properties of fractions. They are improper fractions. So types of fractions. Improper fractions. That is when my numerator is less than my denominator. So the number at the top is smaller than the bottom. For example, 3 out of 4, 1 out of 2, 5 out of 6. Once my numerator is smaller, sorry guys. Proper. Once my numerator is smaller, it's called a proper fraction. Everything looks normal. It's proper. The top is smaller, the bottom is larger. The improper would be the reverse. Right? My denominator is less than my numerator. So for example, this would now be 4 out of 3, 2 out of 1, 6 out of 5. So I have pretend it's a perfect circle with 4 perfect parts. And I have 2 parts shaded out of my 4. So my shaded fraction would be 2 out of 4. My unshaded is still 2 out of 4. So let's say I have a square. And I have a shaded part. So my shaded fraction is 1 out of 4. And my unshaded fraction is 3 out of 4. Again, the part over the total. I have a new shape and I am going to shade 3. How many parts are there in total? 8. So my shaded would be 3 out of 8 and my unshaded would be 5 out of 8. Nice and simple with making fractions, right? what we're going to do is get into the first operation. First two operations, addition and subtraction of fractions. The first thing we need to know about adding and subtracting fractions is that they must have the same denominator. So if I have a half plus a half, I leave my denominators the same, which is 2, and I add the numerators. So it's going to be 1 plus 1, which is 2 over 2. If I have 3 over 4 plus 1 over 4, I'm going to leave my denominator as 4, and I'm going to add 3 plus 1, which is 4 over 4. I must have the same denominator, but sometimes we would not have the same denominator, and we would need to create a denominator, and that is called finding your LCM, lowest common multiple. So for example, we have a half, add a third, not the same denominator, so we need to create a lowest common multiple. So we have to think about a number that 2 could go into and 3 could go into at the same time without leaving a remainder. So 2 could go into 4, but 3 cannot go into 4. 2 could go into 6, and 3 could also go into 6. So 6 is our lowest common multiple. What most people do is they just multiply the two numbers, hint, hint, 2 by 3, right? So now we say, how many times can this denominator go into my LCM? So I say 2 into 6 is 3. And I take that 3 now and multiply it by my numerator, which is 1. And then we say add, because there's an addition sign, and we repeat the process. How many times can 3 go into my LCM, which is 2? And we take that 2 and we multiply by the numerator, so 2 by 1. And then we work this out, which is 3 plus 2 over 6, which is 5 over 6. Right, so what we're going to do now is attempt another one. So let's say 3 over 4 plus 1 over 5. They do not have the same denominators, which is the bottom part. 1 is 4, 1 is 5. So we have to create an LCM. So what number can 4 and 5 go into? The smallest number that they could go into without having a remainder. Little trick, multiply them. 4 by 5, so that's 20. So now we have to say how many times can 4 go into 20? So 4 can go into 20. So 20 divided by 4, same thing. 20 divided by 4 is 5. And we take that 5 and we multiply it by the numerator above the 4, which is 3. So 5 by 3. Plus, We move on to the second one. 20 divided by 5 is 4. And we take that 4 and we multiply it by 1. Which would be 15 plus 4 over 20, which is 19 over 20. Let's do another one. Let's say 4 over 7. Now we're going to do subtract. 1 over 3. Find the LCM, so that's 7 by 3, which is 21. How many times can 7 go into 21? So 21 divided by 7 is 3. And this is going to be 3 by 4. Subtract. How many times can 3 go into 21? That's 7. 7 by 1. So that's going to be 12. We put back the subtraction sign. 12 minus 7 by 1 is 7 over 21. So that's going to be 5 over 21. Now we are going to continue with working out addition of mixed numbers. So mixed number fractions. This includes a whole number and a proper fraction. So something looking like this: 1 1/2, 2 1/4, 3 1/3, etc. These are all improper fractions. So we are going to continue with addition and subtraction of improper fractions. The first thing we have to do is change improper fractions change mixed numbers to improper fractions. And how we're going to do that? 1 1/2. We have to multiply 1 by 2 and add the numerator. So that is going to be 1 by 2 is 2. 2 plus 1. If we're following this 1 by this 2 plus this 1. So it's going to be 1 by 2 is 2. 2 plus 1 is 3. And we put it back over the same denominator. And 3 over 2 is our improper fraction. 2 1/4. 2 multiplied by 4 plus 1. So that's going to be 9 over 4. 3 2/3. That's going to be 3 by 3 plus 2. So 11 over 3. So if I want to change 3 and 2 over 5, or let's say I want to work out 3 and 2 over 5 plus 1 and 3 over 7. So some persons add the whole numbers and then go on to do the fractions separately. I personally think it's a lot of work doing it that way, and you can get complications according to if something is larger, etc. So what we're going to do is change to improper fractions always. So the first one would be 3 multiplied by 5 plus 2. So that's 15 plus 2, which is 17 over 5. And then the second one would be 1 multiplied by 7 plus 3. So that's going to be plus 10 over 3. And we continue like normal. Find our LCM, which is 15. We say 5 into 15 is 3. And we say 17 multiplied by 3. Plus 3 into 15 is 5. 5 multiplied by 10, which will give us 51 plus 50 over 15, which is 101 over 15.
Change into improper fraction.
Change into improper, so that's going to be 7 by 3 is 21, so 22 over 3 minus 2 by 5 is 10, 10 plus 4 is 14 over 5, add 1 by 15 is 15, 15 plus 7 is 22 over 15. Second step is what? Find our LCM, and as we could see nicely, that LCM would be 15. That's 3 by 5 can give me the 15, and then there's also a 15 on the side there, so 15. So I could say 3 into 15 is 5, so that's going to be 5 by 22. Subtract 5 into 15 is 3, so 3 by 14. Add 15 into 15 is 1, 1 by 22. And we take our time and work that out. 22 by 5 is 110 minus 14 by 3, that is 42, plus 22 over 15, and we take our time and work it out. 110 minus 42 is 68, and then 68 plus 22 is 90, so 90 over 50. So all of these final answers here is not really how our final answer should be, but it's the final step before it, right? We have to simplify them. So we are going to do some more simplifying, right? Let's say I have something like 103 over 50. What I have to do now is ask myself, how much times can 103 go into 50? I can use my calculator and I say 103 divided by 50, and I will see 2.06. So I could put 2.06, but what if they want it as a fraction? So this is my decimal answer. What if they want it as a fraction? Simplify it as a fraction. My whole number is 2. And then what I have to do is I have to say 2 multiplied by 50 to get the exact number. So it's going to be 103 minus 2 by the 50, right? So that's 103 minus 100. So my remainder is just 3. So in other words, I take my whole number and I multiply by the denominator, and I subtract it to get the remainder. So my remainder will be 3 over the 50, or put back my denominator. Let's do something else. Let's say I had 25 over 3. How much times can 25? Can 3 go into 25? We know that's an 8. So if you use a calculator and say 25 divided by 3, you'll see 8.333, whatever, etc., right? So I know my whole number is 8. So I can put 8.33 for my decimal, but for my fraction, I have to put 8 and I have to find the number, the remainder. So what do I have to say? Take my whole number and multiply it by 3. So it's going to be 8 by 3, that's 24. And I say 25, subtract 24, which will give me 1 over 3. Right, let's do 2 more. Let's say I have 49 over 9. How many times can 9 go into 49 divided? 49 divided by 9 is 5.44 as a decimal. But if it's a fraction, we're going to put 5, and then we have to say 9 by 5 is 45 and subtract that from the 49, which will give me 4 over 9. If I do 79 over 8, 79 over 8, how much times 10? 79. So 79 divided by 8 in my calculator is 9.875. But if I want it as a fraction, I'm going to have 9, and 8 by 9 is 72. Subtract 72 from 79. That's going to give me a remainder of 7 over 8. Three 11 of 121 of means multiply. So 3 over 11 multiply by, if I'm writing any whole number as a fraction, I just put it over 1. So 3 over 11 multiply by 121 over 1. For multiplication, numerator multiply by numerator, and then denominator over denominator. So 3 by 121 all over 11 by 1. So 3 by 121 is 363. All over 11 by 1 is 11. And we simplify it. 363 divided by 11 is 33. Let's try another one. If I say 5/12 of 144 liters, that's going to be 5/12 multiplied by 144 over 1. And I can say, there's such a thing, I don't know if you all remember, cross division. So I could say, I could divide sideways, or I could divide the fractions. So I can say 12 into 12. I can say 12 into 12 is 1, and 12 into 144 is 12. And then I can say 12 by 5, go back to my cross multiplication. 12 by 5 is 60 over 1 by 1 is 1, which is 60. Or we could have done it the regular way, 5 over 12 by 144 over 1. 144 by 5 is 720 over 12. And when we say 720 divided by 12, we will get 60, right? It's all about your comfort level. And of course, the more we practice, the more we will see certain things, and the more efficient we will become. Right, let's do another one.
Yes, when will we do the one that the first method?
The first method, this?
Yeah, where you're cross divided.
Anyone is fine. If you want to divide it across, once there are two numbers that can divide into each other. So we know that 12 could go into 12 and 12 could go into 144. We divide them. Yeah?
Will we be doing more of that method in the future?
Anyone is fine between this or that?
The first one, I know you didn't show us that before, with the cross dividing. So
right,
I'm saying
so it's not something that you have to do. That's what I'm saying as well. So that's why I did it both ways, right? So we could cross regular 5 by 144 and 12 by 1, or you could do it this way if you see that you want to divide it. You could say 12 into 12, 12 into 144. So let me do two more with that. So let's say we have something like, let's go back to the same one we would have done earlier. 3 over 11 by 121 over 1, right? So we would have done 3 by 121 and 11 by 1 and divided it, right? But if we look at it, 11 could go into 11 once and 11 could go into 121. So it's all about knowing your fractions as well, right? 11 times, right? Because 11 by 11 is 121. So that will now have us as 3 by 11, which is 33, and 1 by 1, which is 1, which is 33. Yeah? So it's the same answers. It's only if you want to do the cross division. I personally don't do it because we have our calculators and we are going to end up with the same answer with less working. But if you do not have a calculator and you have to work this out from scratch, it will be nice for you to know how to divide cross accordingly. So let's say we have something like this, 11 over 121 by 3 over 1. So we could also do the cross division this way, like simplifying, regular simplifying. So we could say 11 into 11 is 1, and 11 into 121 is 11, and that's going to be 1 by 3, which is 3, and 11 by 1, which is 11. We cannot do cross division like this, however. 3 over 121 by 1 over 11. We cannot say 11 to 11 is 1 and 11, so 121 is 11. It's not allowed like that, right? It's either this way or this way. Not straight across. Straight across is for multiplying alone. Yeah? Let's do one more. How about we start adding mixed numbers with it now? So we have 2 and a third multiplied by 5 over 14. Of course, always remember to change your stuff to improper first. So it's going to be 2 by 3 is 6. 6 plus 1 is 7. So 7 over 3 multiplied by 5 over 14. There's nothing to change here. Do we have anything we could cross divide? If we want to cross divide, we could cross divide the 7 and the 14 if we want. 7 into 7 is 1. 7 into 14 is 2, and then continue on. But unnecessary step for me, I'll just say 7 by 5 is 35, and then 3 by 14 is 42, and I could simplify. Are there any numbers that are going to 35 and 42? 7. So 35 into 7 into 35 is 5, and 7 into 42 is 6. So we end up with 5 over 6. I want to show you all how to simplify fractions in your calculator. Did I lose anyone? Did I lose anyone?
No, miss.
No.
All right, so I'm going to do one last one. So we are seeing everything just combining and coming together, right? Let's do one last one. Five and 3 over 5 divided by 1 and 5 over 9. First step is improper, which would be 25, 28 over 5 divided by 1 by 9, 14 over 9. Change it, 28 over 5 multiply by 9 over 14. Cross divide if you want. We could cross divide and say 14 into 14, 1, 14 into 28, 2. And then we say 2 by 9 is 18, 5 by 1 is 5, and then we say 5 could go into 18 3 times. That's 15 minus from 18, that would be 3 over 5. Right, so everything is being combined now, but we understand the concepts of everything. I'm just going to do a quick recap before we go. Right, so for addition and subtraction, we have to change to improper fractions, right? That is, of course, if they are not proper fractions. If they are mixed numbers, we change them to improper fractions. If they are proper fractions, we proceed to finding the LCM. So if I have 4 and 3 over 5, add 1 over 3, I must say 4 by 5 is 20, plus the 3, 23 over 5, add 1 over 3. Then I find my LCM, which is 15. I find my LCM, which is 15. And I must say 5 into 15 is 3, and then 3 by 23. Add 3 into 15 is 5, then 5 by 1, which is 69 plus 5 over 15, which is 74 over 15. And I could work this out in my calculator. I could even put 74 fraction sign 15, and they will give me my full answer, right? 74 fraction sign 15. And they are telling me that my answer is 4 and 14 over 15. So that's addition and subtraction. Change the LCM, change the improper, find your LCM, take your time and do your division for your denominators and your LCM, do your multiplication, simplify it, and then simplify your final answer. That's for addition and subtraction. Now for multiplication, no LCM. So all we do is numerator by numerator over denominator by denominator, right? And we simplify our answer. For division, all we have to say is n over a divided by b over c is n over a, multiply by, switch it, c over b. And then we go back to working out our stuff, n by c over a by b. So I know that it was a little crammed the class, but time flies because 2 hours is gone already, right? But I would hope that you will have the understanding of certain things, and it's just for you to practice it now. And if you have any questions, feel free to let me know. We will stop here today.